So we've already seen in this module that having a normal distribution is very handy. It allows us to quickly determine areas and probabilities. And we've also seen that when our original populations are not even normal themselves, that a normal distribution can arise through the concept of the distribution of sample means or the distribution of sample proportions. But in order for those distributions to be normal, remember, for the distribution of sample means, we needed the sample size to be at least 30, and then we also had sample size conditions set on the distribution of sample proportions. So what happens in the scenario when we're dealing with a small sample? Well, one of the things that we do when we have a small sample is we say, hey, if we can determine that this small sample is coming from an approximately normal population, then we're back at working with a normal distribution potentially again. And so that's what we're going to look at in this video. We're going to look at some of the tools that we've seen in the past, and based upon those tools, we're going to see if our samples are suggesting that our original population was approximately normal or not. And so what are we going to look at, or what are we going to look for when we go back to some of those old tools? So we're going to be looking for major red flags that our sample is coming from a non-normal population. And so some of those red flags are things like multiple modes, or a large degree of skewness, or possibly an outlier or two in that small sample. So let me write these down. So some signs of non-normality include the following. So we're looking for multiple modes. We are looking for that skewness, and it's a large degree of skewness. And then we're also looking for an outlier or two. Now, just because we end up with a sample that maybe does not have any of these red flags does not necessarily imply that the original population is approximately normal. But in statistics, a lot of times we make assumptions, and in this class, that's what we're going to do. So let's take a look at some examples right now, and as we go through the examples, I want to show you, in some cases, a small sample that is coming from an approximately normal population, and in other cases, samples that are not. So start with the dot plot in this first picture. So I've actually got two dot plots here, and when you look at the very top dot plot, you can see that you've got this one point from our small sample that is very far removed from all of the other values in that small sample. So if you've only got 5 sample values and one of them is that far away from everything else, then chances are that this is an outlier relative to these values, and that would speak to the fact that our original population would not be approximately normal. So I would say, no, this picture is not reflective of a small sample coming from an approximately normal population. But the bottom one, I think, might be coming from an approximately normal population, because you see that we have this value out here, and we have this value here. So we have a good spread of the data, but there appears to be like a good clustering of values right in the middle. And so I'm kind of envisioning a normal population, and it is entirely possible, if I had a normally distributed population and I drew a sample of what appears to be about 10 values, that we would see a spread of those 10 sample values like we see here. So this to me would be a yes. I would say, yes, that is coming from an approximately normal population. Let's take a look at the histogram. So one of these histograms is coming from an approximately normal population, and one of them is not. And as you can probably tell, the one that is coming from an approximately normal population would be this top one. In fact, if this is a sample or a histogram of the sample, you can even envision a normal-like distribution for that sample. And so this one might even be a little bit easier than the dot plot above. Now, when you look at this bottom one, we would most likely say, no, this is not coming from an approximately normal population, because a normal population would have would produce some sample values that would most likely peak in the middle. And while we have some peaking going on right here in our sample, to have this big drop off right here I wouldn't go so far as saying that this necessarily has multiple modes, but this certainly does not mimic any type of behavior from a normal distribution, because like I said, this all should be kind of peaking in the middle. And given that this is one of the lowest bars in this histogram, tells me this sample is not likely coming from an approximately normal population. Okay, let's take a look at a couple of other examples. So here is some other images that we've worked with in the past. We've talked about stem and leaf plots, and we've also looked at box plots. And when you take a look at this stem and leaf plot, you can see that there's naturally a certain level of skewness to this. And you can see that if you were to kind of sketch a curve over the top of our distribution of numbers in this stem and leaf plot, that the stem and leaf plot is very heavy on the left side of it, or the top side of it, if you want to think of it like that. And so I think if you even turn your head and look at this from the side, you might describe this as being a distribution that is skewed to the right. And so given this skew to the right, I would say that this is not coming, this is not coming from an approximately normal population. But then when you take a look at the box plot in the very last picture, I think this one is coming from an approximately normal population. We don't see any outliers. You know, sometimes with box plots you would see those X's kind of in one extreme or the other. And then the other thing is, you know, where this median line is, it suggests that, you know, 50% of your data in this sample is going to be less than that line, 50% is going to be above that line. The fact that this line is pretty close to the middle and that we have a relatively similar stem on each end of this tells me that it is entirely possible that if this box plot is representing my sample, that my sample is coming from an approximately normal population. So those are some of the things that we're going to be looking for in those older tools that we've worked with. And in the next video, I want to show you something called a normal quantile plot, which is a final tool that we're going to use in the calculator so that we can assess the normality of a population from a small sample.